What if the world's greatest cities weren't destroyed by rising oceans, but deliberately sunk beneath them? Imagine massive titanium megacities resting on the seafloor, protected from storms, powered by the ocean itself, and becoming humanity's last hope. Is this impossible science fiction, or the blueprint for our future? Today on Earth Discovery 360, we're diving into the incredible world of the Titanium Reef. For thousands of years, humanity built its greatest civilizations beside the sea. From New York and Tokyo to Shanghai, London and Dubai, oceans brought trade, food, transportation, and prosperity. Nearly half of the world's population now lives near a coastline. But what once made these places powerful may soon become their greatest vulnerability. Scientists have warned for decades that our planet is warming. As global temperatures rise, glaciers and polar ice sheets slowly melt while warmer oceans expand, causing sea levels to climb. Even a relatively small increase in sea level can make storm surges more destructive, increase coastal flooding, and threaten infrastructure. These risks are already being studied around the world, although the exact impacts will vary by region and future greenhouse gas emissions. Now, imagine standing on the shoreline 50 years from today. The beach where children once played has disappeared. Roads are underwater. Ports no longer function. Entire neighborhoods are protected only by enormous sea walls that become taller every decade. Governments spend trillions of dollars fighting an enemy that never sleeps: the ocean itself. At first, humanity believed bigger walls would solve everything. Then higher pumps, then artificial islands. But eventually one terrifying question emerged. What if we stopped fighting the ocean and learned to live with it instead? That single question changed the future of civilization. Engineers, marine biologists, architects, and climate scientists from around the world gathered to imagine something that had never existed before. Not another floating city, not another coastal barrier, but a completely new kind of civilization, a city built beneath the waves. Its foundation would never rust like ordinary steel. Its structure would survive crushing ocean pressure. Its walls would become living habitats where corals, fish, and marine ecosystems could thrive. The project received a bold name: the Titanium Reef. Unlike traditional underwater bases designed for research or military missions, the Titanium Reef was imagined as a permanent home for millions of people. Giant titanium frameworks would support transparent residential domes, research laboratories, hospitals, schools, vertical farms, and clean energy systems powered by the ocean itself. From above, satellites would see almost nothing. But beneath the surface, an entirely new world would glow with light. High-speed transit tunnels would connect underwater districts. Artificial reefs would attract marine life. Advanced desalination plants would produce fresh drinking water. Ocean currents would help generate electricity. Instead of damaging the sea, the city would be designed to become part of its ecosystem. It sounded like science fiction, yet many of the technologies needed already exist in smaller forms today. Researchers continue exploring floating communities, offshore infrastructure, artificial reefs, advanced underwater engineering, and climate adaptation strategies. Although true underwater megacities remain a speculative future concept rather than a current reality. The question was no longer whether humans could build beneath the ocean. The real question became, would we have to? Because every year, the ocean moves a little farther inland. Every year, another community faces stronger flooding. Every year, humanity is forced to rethink where the future belongs. Perhaps the next great civilization won't rise into the sky. Perhaps it will disappear beneath the waves, and hidden on the seafloor, surrounded by silence and illuminated only by blue ocean light. The first Titanium Reef may become humanity's greatest engineering achievement. In part dos, we'll explore how engineers could actually construct an enormous titanium megacity on the ocean floor and why titanium may be the only material capable of surviving for centuries beneath the sea. Imagine trying to build a city where the pressure is hundreds of times greater than at the surface. Every square meter must withstand enormous forces. Saltwater constantly attacks exposed materials, and even a tiny structural failure could become catastrophic. This is why ordinary steel and concrete alone would not be enough. Engineers have long used titanium in submarines, spacecraft, and specialized marine equipment. Because it is strong, lightweight, and highly resistant to corrosion in seawater. These real-world properties inspire the futuristic idea of a titanium reef, even though such a megacity does not exist today. Construction would begin with autonomous underwater robots mapping the seabed in extraordinary detail. They would search for stable bedrock, avoid fragile marine ecosystems, and identify areas least vulnerable to underwater landslides or earthquakes. Once the location was chosen, thousands of robotic construction vehicles would assemble massive titanium support frames piece by piece on the ocean floor. Instead of building upward like today's skyscrapers, the city would spread outward like a living coral reef. Giant pressure-resistant domes would be connected by reinforced tunnels, creating separate districts for homes, hospitals, schools, research centers, and indoor farms. If one section ever needed maintenance, it could be sealed without affecting the rest of the city. Electricity could come from multiple renewable sources working together. Offshore wind farms, floating solar platforms, tidal turbines, and ocean thermal energy systems might provide continuous power. Fresh water would come from advanced desalination plants, while vertical farms and aquaculture systems could supply much of the city's food. Outside the domes, specially designed artificial reef structures would encourage coral growth and provide habitat for fish and other marine life. Instead of becoming an environmental scar, parts of the city could potentially function as new marine ecosystems, if carefully designed and managed. Artificial reefs are already used in some locations to support marine habitats. Although an entire underwater metropolis remains purely speculative, inside, life would feel surprisingly normal. Parks filled with natural light delivered through fiber optic systems, quiet electric transportation, clean air recycling, and panoramic underwater observation galleries would make the city feel less like a bunker and more like the next evolution of urban living. But one enormous challenge would remain. How do millions of people safely travel between the surface and a city resting deep beneath the ocean? That transportation system would become one of the greatest engineering projects in human history. Building the Titanium Reef would only solve half the challenge. The next question would be even more important. How could millions of people travel safely between the surface and an underwater city every single day? Traditional submarines would be far too slow and expensive for everyday transportation. Instead, engineers imagine a network of gigantic ocean elevators, vertical transit towers, extending from the surface down to the underwater metropolis. While no such passenger system exists today, it draws inspiration from existing offshore platforms, deep-sea engineering, and pressure-controlled underwater habitats. Each tower would float above the city like a futuristic island. At the surface, ships, emergency vessels, cargo drones, and aircraft could dock on massive platforms. Hidden beneath them, ultra-strong, pressure-resistant elevator capsules would descend through reinforced shafts, carrying hundreds of passengers at a time. As the elevator traveled deeper, passengers would watch sunlight gradually fade. Schools of tuna would race alongside the transparent observation windows. Giant manta rays might glide silently through the blue water, while glowing jellyfish illuminated the darkness below. Eventually, the city itself would appear a breathtaking skyline of titanium towers, glowing domes, and coral-covered structures shining beneath the sea. Freight transport would use separate high-capacity cargo elevators. Food, medicine, construction materials, and scientific equipment could move continuously between the surface and the underwater districts. Artificial intelligence would coordinate every movement, preventing delays and ensuring that emergency supplies always had priority. Safety would be designed into every layer of the system. Multiple backup elevators, emergency escape capsules, independent power supplies, and sealed pressure chambers would allow passengers to survive even if one section experienced a failure. Advanced monitoring systems would constantly inspect every structural component for microscopic cracks long before they became dangerous. The elevators would also serve another purpose. They would become research stations. Scientists could monitor ocean temperatures, currents, marine biodiversity, and changing sea levels in real time, turning the transportation network into one of the largest climate observation systems ever created. From above, these towers would look like futuristic islands scattered across the ocean. Below the waves, they would become the lifelines connecting to worlds. But even with perfect transportation, another challenge remained. Could people actually live for years beneath the sea without sunlight, fresh air, and open skies? That question would transform not only engineering but human psychology itself. Living underwater might sound impossible at first. Humans have evolved under open skies, fresh air, and natural sunlight for thousands of years. But if rising sea levels forced coastal populations to relocate, future engineers and psychologists would face an entirely new challenge, not just building an underwater city, but creating a place where millions of people could truly feel at home. Inside the Titanium Reef, every neighborhood would be designed to recreate the comfort of life on the surface. Advanced LED lighting systems would simulate sunrise, bright afternoons, colorful sunsets, and peaceful moonlit nights. Artificial intelligence would adjust the lighting throughout the day to help maintain healthy sleep cycles, supporting both physical and mental well-being. The city's air would be continuously purified using advanced filtration systems and oxygen, generated through a combination of electrolysis and carefully managed indoor plant ecosystems. Large botanical gardens filled with trees, flowers, and flowing waterfalls would become peaceful public spaces where residents could relax, exercise, and enjoy the feeling of nature even hundreds of meters beneath the ocean. Food production would also be transformed. Instead of depending entirely on imports, enormous vertical farms would grow vegetables, fruits, and grains year-round using hydroponic and aeroponic systems. Nearby aquaculture facilities could sustainably raise fish and shellfish, reducing transportation costs while providing fresh food every day. These technologies already exist on smaller scales and continue to improve, although supporting an entire underwater megacity remains a futuristic vision. Children would attend schools equipped with immersive virtual classrooms connected to teachers and students around the world. Hospitals would use robotic surgery, AI-assisted diagnostics, and high-speed communication links to collaborate with medical experts on the surface. Scientists could study marine ecosystems just outside the city, making discoveries without long submarine expeditions. Perhaps the most extraordinary feature would be the windows. Instead of looking out over busy streets, families could watch dolphins swimming past their homes, sea turtles gliding through coral gardens, or enormous whale sharks peacefully crossing the deep blue ocean. Every day would offer a different view, shaped by the rhythms of the sea rather than traffic or weather. Yet life underwater would never be completely free from danger. Far below the surface, hidden geological forces constantly reshape the ocean floor. Earthquakes, underwater volcanoes, and massive landslides could generate powerful pressure waves capable of threatening even the strongest structures. If the Titanium Reef was going to survive for centuries, it would need a defense system unlike anything humanity had ever built. Building the Titanium Reef would be one of humanity's greatest engineering achievements, but keeping it safe would be an even greater challenge. Deep beneath the ocean, the city would face dangers that no modern metropolis has ever experienced. Earthquakes, underwater landslides, extreme pressure, powerful ocean currents, and even the rare possibility of tsunamis generated by undersea events would all have to be considered in its design. Instead of relying on a single massive structure, engineers would divide the city into hundreds of independent modules. Each residential district, hospital, research center, and farming zone would operate like its own self-contained neighborhood. If one section were damaged, giant pressure doors could automatically seal it within seconds. preventing flooding from spreading throughout the entire city. Thousands of AI-powered sensors would constantly monitor every titanium beam, support column, and pressure seal. These systems could detect microscopic structural changes long before they became dangerous, allowing maintenance robots to repair small problems before they turned into major failures. Similar structural health monitoring systems are already used on bridges, offshore platforms, and other critical infrastructure today, although not at the scale imagined for an underwater megacity. Outside the city, fleets of autonomous underwater drones would patrol day and night. Some would inspect pipelines and energy systems, while others would monitor marine life and changing ocean conditions. Advanced sonar networks could detect unusual seismic activity or underwater landslides, giving residents valuable time to prepare if an emergency developed. Power systems would also be fully redundant. If tidal generators stopped working, floating offshore wind farms could continue supplying electricity. If one energy source failed, battery storage systems and backup reactors could immediately take over, ensuring that hospitals, communication systems, and life support equipment never lost power. Every resident would participate in emergency preparedness training. Schools would practice evacuation drills, hospitals would maintain independent life support reserves, and emergency shelters would contain food, water, and medical supplies capable of supporting entire communities for weeks, if necessary. Yet, the greatest lesson of the Titanium Reef would not be about survival. It would be about adaptation. For thousands of years, humanity reshaped rivers, forests, deserts, and mountains to build civilization. Now, for the first time, civilization would be designed to exist in harmony with the ocean instead of fighting against it. The sea would no longer be humanity's greatest threat. It could become humanity's greatest ally. In Part 6, we'll explore how the Titanium Reef could transform the global economy, create entirely new industries, and redefine what it means to live on planet Earth. If the Titanium Reef ever became reality, it wouldn't just change where people lived, it could completely reshape the global economy. For thousands of years, major cities grew around rivers, ports, and coastlines because trade depended on ships. But in the future, the ocean itself could become humanity's largest economic frontier. Imagine hundreds of underwater districts connected by high-speed transit tunnels and autonomous cargo submarines. Instead of trucks crossing highways, fleets of robotic underwater vehicles would transport food, medical supplies, construction materials, and scientific equipment between ocean cities, offshore platforms, and coastal hubs. Artificial intelligence would coordinate every delivery, creating a transportation network that operates day and night without traffic congestion. Energy production would become one of the city's greatest strengths. Powerful tidal turbines could generate electricity from constantly moving ocean currents. Floating offshore wind farms and advanced solar platforms would add renewable power, while ocean thermal energy systems could use temperature differences between warm surface water and colder deep water to produce electricity. These renewable technologies already exist or are being actively researched, though integrating them into a massive underwater city remains a future concept. The Titanium Reef would also become one of the world's most advanced scientific centers. Marine biologists could study deep-sea ecosystems without long research expeditions. Climate scientists could monitor ocean temperatures, carbon storage, and changing currents in real time. Engineers would test new underwater construction methods, while doctors could develop medicines inspired by organisms living in the deep ocean. Tourism would be transformed as well. Visitors from around the world could stay in transparent underwater hotels, dine while sharks and manta rays swam overhead, or explore coral gardens through guided submarine tours. Instead of simply visiting the ocean, people would experience life inside it. Entirely new industries would emerge. Companies specializing in underwater robotics, pressure-resistant architecture, ocean agriculture, desalination technology, marine renewable energy, and advanced environmental restoration could create millions of highly skilled jobs. Most importantly, the Titanium Reef could help reduce pressure on crowded coastal regions. As rising sea levels continue to threaten some communities, future ocean-based infrastructure might provide additional living and research space while protecting valuable ecosystems above the surface. However, experts continue to emphasize that reducing greenhouse gas emissions and adapting existing coastal communities remain the primary real-world priorities today. For the first time in history, humanity would stop seeing the ocean as the edge of civilization. Instead, the ocean would become civilization itself. But one final question remained. Could an underwater city truly coexist with nature, or would it become another human project that damages the very environment it was built to escape? That answer would determine whether the Titanium Reef became humanity's greatest achievement or its greatest mistake. For centuries, humanity has treated the ocean as something to conquer. We built seawalls, reclaimed land, dredged coastlines, and expanded cities farther into the sea. But the Titanium Reef would represent a completely different philosophy. Instead of forcing nature to adapt to us, humanity would adapt to nature. Every part of the city would be designed to work with the surrounding marine environment. Artificial reef structures attached to the titanium framework could provide new surfaces where corals, sponges, oysters, and countless other marine organisms might grow. Around the world, carefully designed artificial reefs are already being used in some places to help create habitat for marine life. Although results depend on local conditions and cannot replace the protection of natural reefs, powerful AI systems would constantly monitor water quality, oxygen levels, ocean acidity, and biodiversity. If pollution increased or a harmful algal bloom appeared, environmental control systems could respond immediately while scientists investigated the cause. Waste management would operate as a closed-loop system. Water would be purified and reused. Organic waste could be converted into fertilizer or renewable energy. Plastics and metals would be recycled inside the city instead of being released into the ocean. The goal would be simple. Nothing harmful leaves the Titanium Reef. The city's underwater farms would also help reduce pressure on land. Vertical hydroponic gardens could produce fresh vegetables year-round, while sustainable aquaculture systems would carefully manage seafood production using advanced environmental monitoring. Every resource would be tracked by artificial intelligence to minimize waste. Residents would experience the ocean in ways no previous generation ever had. Children might attend classrooms where enormous whales slowly passed outside the windows. Marine biologists could study deep-sea creatures just minutes from their laboratories. Families could enjoy underwater parks illuminated by soft blue light, surrounded by schools of colorful fish moving peacefully through living coral gardens. Instead of fearing the sea, people would become part of its rhythm. But nature is never completely predictable. Climate change could alter ocean temperatures, powerful storms could affect surface infrastructure, and changing currents might influence marine ecosystems in unexpected ways. Scientists would need to continuously adapt the city as new discoveries were made. Real-world experts emphasize that protecting healthy oceans still begins with reducing pollution, limiting greenhouse gas emissions, and conserving existing marine habitats, not relying on future megaprojects alone. The Titanium Reef would therefore become more than a city. It would become a living laboratory, one where every decision was measured not only by human success, but also by the health of the ocean itself. Because humanity's future would no longer depend on conquering the sea. It would depend on earning its place within it. For thousands of years, human history has been shaped by migration. Our ancestors crossed deserts, climbed mountains, sailed across vast oceans, and explored unknown continents in search of a better future. Every great civilization began with people willing to move toward opportunity. But the greatest migration in history may not happen across land. It may happen beneath the sea. Imagine the year 2150. Coastal flooding has become increasingly common in many parts of the world. Some low-lying communities have relocated inland, while others have invested heavily in flood defenses and climate adaptation. At the same time, new technologies have made permanent underwater habitats more practical than ever before. In this future scenario, the Titanium Reef is no longer a bold experiment. It has become one of several next-generation ocean cities designed to complement life on the surface, not replace it. The first families arrive through the massive ocean elevators. As the elevator doors open, they don't step into a cold industrial facility. They enter a vibrant city. Children laugh in spacious parks filled with tropical plants. Autonomous electric transit glides silently through crystal-clear tunnels. Schools, hospitals, research centers, and homes are illuminated by advanced daylight simulation systems. Outside the transparent domes, sea turtles drift gracefully through forests of living coral. For many newcomers, the first few weeks are emotional. Some miss the open sky. Some miss the sound of rain. Others struggle to believe they are living hundreds of meters beneath the ocean, but gradually, life begins to feel normal. A new generation grows up knowing the underwater skyline is home. To them, watching whales swim past the classroom window is as ordinary as watching birds outside a school today. Scientists, engineers, teachers, doctors, artists, and entrepreneurs from every continent help build a unique culture unlike anything in human history. National borders become less important. The ocean belongs to everyone. Different languages, traditions, and ideas merge into one international community connected by science, sustainability, and innovation. The Titanium Reef becomes more than an engineering project. It becomes a symbol of humanity's ability to adapt. A reminder that civilization does not have to end when the environment changes. It can evolve. Of course, this vision remains speculative. Today's efforts remain focused on strengthening coastal resilience, reducing climate risks, and exploring innovative designs such as floating communities and other adaptive infrastructure. Underwater megacities like the Titanium Reef are still part of future-oriented imagination rather than current engineering reality. And perhaps that is the greatest lesson. Humanity has always survived not because the world stayed the same, but because we learned to change with it. In the final episode, we'll ask one last question. Could the Titanium Reef become the blueprint for humanity's future not only on Earth, but on distant ocean worlds beyond our solar system?